Alright, so hey there, this video is on how to calculate the mass percent composition of an element in a compound if you know what the formula of the compound is. So let's start out with the definition of mass percent composition of an element in a compound. It's just the mass of that element that's in that compound divided by the total mass of that compound times 100%. So we need to know basically two numbers: how much that element in that compound weighs and how much that compound weighs. So let's look at that. So to get the mass of an element in a compound, remember, we already know the formula. If you don't know the formula, then it's a slightly different story. But let's say we know the formula. The mass of an element in a compound is just the average atomic mass of that element, which we know by looking at the periodic table, multiplied by how many atoms of that element there are in the compound. We get that from the formula. And if we know the mass of all the elements that are in the compound, to get the total mass of the compound, we just add them all up. And watch. So let's say we're looking at methane, CH4. Well, the mass of carbon in that compound is, there's one carbon, and each carbon weighs 12.011 AMUs. We get that from looking at the periodic table. Remember, AMU is a unit of mass, that atomic mass unit. And hydrogen, we know from over here, the periodic table, weighs 1.008 AMUs. And there are 4 hydrogens, so we're going to have to multiply the mass of hydrogen, the 1.008 AMUs, times 4 to get the total mass of hydrogen in that compound. Now the total mass of that compound will just be the mass of carbon right here, plus 4 times the mass of hydrogen. So let's calculate the mass percent of hydrogen and carbon in methane. So mass of carbon in 1 molecule of methane is, there's 1 carbon, we know from the formula, times the average atomic mass of carbon from the periodic table, 12.011 AMUs, and that's equal to 12.011 AMUs. The mass of hydrogen in 1 molecule of methane will be 4, because there's 4 hydrogens, times the mass of hydrogen, the average atomic mass, which is 1.008 AMUs. Multiply that out and you get 4.032 AMUs for the total mass of hydrogen in methane, CH4. So to get the mass of 1 molecule of methane, CH4, we just add together the total mass of carbon plus the total mass of hydrogen. So carbon weighs 12.011 AMUs and hydrogen weighs 4.032 AMUs in methane because there's 4 hydrogens. Total mass of 16.043 AMUs. Now remember, the mass percent composition of an element is just the mass of that element in the compound divided by the total mass of that compound. Well, the mass percent of hydrogen then in methane would be the total mass of hydrogen, which is 4.032 AMUs, divided by the total mass of methane, 16.043 AMUs, times 100%, which gives us 25.13%. And the mass percent of carbon in methane would be the mass of carbon, there's just 1, so it's 12.011 AMUs, divided by the total mass of methane, 16.043, we got it from up here, times 100%, which gives us 74.868%. Notice these don't quite add up to 100, and that's just because of rounding.